All right, we'll derive another property for Laplace transforms in this video, and this will actually help clarify lines 7 through 10 of the Laplace transform table. So this property says if we know the Laplace transform for some little f of t, it's going to be big F of s, and it exists for s greater than 0, then we want to be able to calculate the Laplace transform of e to the ct times that function. Seems pretty natural. E to the ct comes up all the time in differential equations. So it'd certainly be nice to have a formula for this. Same thing as in the previous video, we're going to derive it from first principles, and then we'll never have to do all this work again. This actually isn't so much work. F of t e to the minus st dt. It's a formula for Laplace transform. And then we're going to do the reverse of what we normally do. We're going to combine these e's actually into a single exponential. F of t e to the minus st plus ct dt. And then I can factor out a negative t is what I'll factor out in that exponent. So e to the negative t times s minus c dt. And notice this looks a lot like the Laplace transform for f, except that there's an s minus c instead of an s. Well, that doesn't depend on t. So actually, this is the Laplace transform for f of t, but with the variable being s minus c instead of s. Or in other words, we have this convenient notation, big F of s minus c is what that is. Okay, so that's the formula. Laplace transform of e to the ct f of t is big S of s minus c. And this exists for, it should have been s greater than a. So exists for s minus c greater than a, which actually really means s is greater than a plus c. Okay, so let's look in the table about where that comes up. And we can see lines 7 through 10, not 7 through 10, 5 and 6 going to 9 and 10. I lied earlier. Okay, 5 and 6, we had the Laplace transform for sine at and cosine at. And we're going to replace that with a b, apparently, from 9 to 10. So replace it with a b, but also replace the s with s minus a because of this formula we just derived. We're multiplying by e to the ct, so we're replacing the s with s minus c. And here, c is a. Same thing going from line 3 to line 11. Notice this formula, all it does is replace the s with an s minus a, because we're multiplying by an e to the at. So those are pretty easy to handle, which is not surprising. E to the at or ct has been pretty easy in all of differential equations.